Well, I think there are new paradigms which are relating the morphology to functionality and spanning all over the brain, let's say on centimeters, and connecting the nanometer region's behavior with the centimeter region's behavior. It's pretty much interesting. Think about some pathologies like Alzheimer. I mean, the amyloid plaques deposition is just the ultimate, let's say, stage, and when the pathology is assessed. But many people think that the pathology starts much before, when you have some functional problems at maybe single cell or single synapse level. So being able to detect those kind of malfunctionings would be very, very interesting to detect early stage. So at that point, I think that addressing new pharmacological targets to address those kind of problems, not only at the nanometer level, but also at the centimeter levels, would be very interesting. Think about autism, for example. An autistic guy was thought at the beginning to be just a matter of psychologists, it's behavioral problems. Then they understood that there is some chemistry behind it. They moved from psychologists to psychiatrists. Now we understand it's a problem of cytoarchitecture of the cerebellum. So it's not anymore a nanometer problem, it's a centimeter problem. So we have to realize new pharmacological targets that are somehow reshaping somehow the cytoarchitecture of the brain. So there are completely new problems, and which are not known before, because we did not have before the technological challenge to connect the nano world to the macro world. Well, it's difficult to say that there is one killer application, one killer technology. It does not exist. I mean, I strongly believe that the multimodal approach will be the best, because every kind of techniques, every kind of imaging techniques has its own features. So there are techniques which are capable to visualize in super resolution, but as the disadvantage, for example, to go on narrow regions or maybe very superficial. There are other techniques which allows you to go deeper, but they lose resolution, but are only in ex vivo. There are other techniques which go deeper, but are in vivo, but on the other side has very low resolution. So all those kind of techniques are complementary. So I think that in order to have an extensive, let's say, vision of the brain, you need to put all those techniques all together, correlating each other. So having a multimodal, multi-level approach that will enable us probably in the future to, let's say, have a more extensive, let's say, vision. Nowadays we have some very established clinical, let's say, methods like fMRI or DTI to track, for example, fibers. And but the disadvantage of those techniques are that resolution is very poor. So if we are now able, by using the animal model, to reinterpret fMRI signals with much higher resolution techniques, they will be able maybe not to use those imaging techniques on humans because it's not possible, but to reinterpret, to have new paradigms of interpretation of the fMRI. And that would be extremely interesting to discover, new kind of features of pathologies.